My name is Paul Steen. I work with the Huron River Watershed Council, which has been a partner in the MiCorps and the Clmp programs since 2004. And I've been doing this since 2008. So I'm now 14 years in, and this is the 13th CLMP training that I have participated in. Um, in the old days, I would give every single presentation, and I wasn't making sense by the end of the day. And so I'm very grateful to have Eric on board now the last few years to lead up the CLMP. He's a really knowledgeable limnologist. Um, but I'm still around and I still contribute to the CLMP in various ways. And then, as Joe said at the beginning, I do a lot of stream work through MiCorps as well. But been around a while. Always happy to be working with volunteers and teaching this material because I I'm really passionate about it. I love lakes. I love water quality discussions. So I'm happy to be here to go through chlorophyll with you. So for my part, this is our outline for right now. We're going to talk about what chlorophyll is. We'll talk about the schedule. We'll talk about the process, both the water collection and the sample filtering. Chlorophyll has a more longer, trickier process than the other parameters. So there's lots of little pieces. We want to make sure we cover all of those. And then we'll talk a little bit about data at the end. So let's start with what is Chlorophyll-a? Like the other parameters that Eric mentioned already, it's one of our trophic state indicators. So it's a measurement of the trophic state or the productivity of a lake. And that is because chlorophyll is basically the bottom of the food web for your lake community. It's a small single-celled organism that often combines into colonies, and it serves as the really as the food for everything above it. And the reason we study it in this program is that it is directly fueled by the amount of nutrients in a lake. So the more phosphorus you have, the more chlorophyll you have, and the two are very tightly correlated, but it's good to get both of those measurements to get the complete picture. So chlorophyll-a, why do we refer to it as chlorophyll-a? Chlorophyll comes in many different forms. There's a chlorophyll-a, a B, a C, a D. They all have slightly different structures and are found in different types of algae and plants. Chlorophyll-a is the most commonly found chlorophyll in green plants and algae in this part of the world. So it provides the best. If we're only going to quantify one of them, it provides the best and the most accurate measure of chlorophyll in your lake. A lot of this is in nuts and bolts. So Eric really got into the limnology really well, kind of the reasons why we do these things. Chlorophyll is very particular in its process, so I spend quite a bit of time talking about the process itself. So that's actually what we're going to just jump right into. And this looks familiar to you because this is the same type of format that we use for our phosphorus schedule. So in the same, how you read this is in the same way, in the same vein as phosphorus. You'll find your county on the left-hand side. You'll see the next column is where you're going to be bringing your samples. And then the third column is when you're supposed to be taking your chlorophyll samples. There's 5 samples that we want you to do. They all happen in the different months, May, June, July, August, September, except if you're in the UP, you may be taking samples 4 and 5 both in August. You'll have one in the middle of August and one at the end of August because of weather and climatic differences. So, you want to refer carefully to the schedule to make sure you get the exact right time, especially in that sample number 5. And then notice there's 2 turn-in dates. You'll turn samples 1 and 2 in on June 21. Now, remember, this is the same date that you're turning your spring phosphorus sample in. So you'll still only have to make that one trip to the drop-off location. And then samples 3, 4, and 5 have a different turn-in date, and that's the same date that you will turn in your summer phosphorus. So don't forget one of those things in your freezer when you're headed out to do the turn-ins on those particular days. You want both your chlorophyll and your phosphorus going with you. Why do we do 2 different sample dates? Well, chlorophyll, there's 2 reasons really. Number 1, we want to get the samples to the lab as quick as we can so they don't have a big backlog at the end of the season. The second reason is that we like to catch mistakes early. So if you make a mistake in your samples 1 and 2, we can see that and make sure to communicate those mistakes to you prior to you taking samples 3, 4, and 5. So then maybe you've only messed up 2 samples instead of all 5 of them. So that kind of is the reasoning for why we do this particular schedule. So because of that, there's 2 turn-in dates. You'll also have 2 chlorophyll data forms because you'll have data form 1, which is for May and June, and then you'll have a separate piece of paper that is chlorophyll data form 2 that covers the other months. So only fill in the proper data forms for the proper samples. Well, I'll show you more data forms later when we talk about filling them out. Now, similar to SECI, there's a reason for why we take measurements throughout the summer and not just all once or twice. That's because lakes change over time, as Eric mentioned, and the chlorophyll-A, the amount of chlorophyll-A in your lake will change throughout the course of the summer as the algae population and community changes. So that's why we do all 5 measurements. We want you at a minimum to make sure you get 4 of the 5 months. If you only get 3 of the 5 samples, that's not enough to properly say we have a full good look at what's going on in your lake that summer, and it will not be added. If you only get 3 or 2 or 1, those results will not get added into the long-term trending, looking at your lake over time. We'll still hold on to those samples that you did do, and they'll be in the database, but we won't be able to calculate medians, and we won't be able to calculate TSI scores. So you really need 4 or 5 samples. Okay. I'm going to stop sharing just for a second so you can zoom up more on my face, because I'm going to show a few pieces of equipment. You could grab, if you got it in the mail already, you can grab your chlorophyll samples and your equipment and have it in front of you. If I'm still a small little thing on the screen, you can click on my picture and make me bigger. So I'm just going to show you a few of the trickier pieces of equipment that will come in the mail for you. First off is this 60 millimeter syringe. Okay, I guess that's pretty straightforward. What I wanted to show you with this is that you will also get this piece of Tygon tubing, and you'll notice that your syringe has threading here. The Tygon tubing does not, and that's okay. That's how it's supposed to be, all right? Because at some point in the procedures in a little bit, you'll see how we are going to attach these 2 things together, and it does work. You just have to push and twist and ream it on there good so it's a nice tight seal. but the threading actually on there, it's not designed to particularly thread in. All right, so you can see, I know I'm going in and out a little bit with my background, but yeah, you can see that works. The other thing I wanted to show you close up is this strange contraption. This is called the filter holder. So this is where your little piece of filter paper will go in. This thing unscrews, and in here, there's a little O-ring, little rubber O-ring to get a nice tight seal when you got your filter paper on there. So don't lose this. You need it. Without this, the whole thing will leak, and you won't get good samples. So you see there's like a little screen on there, and we'll put our filter paper on that to help us get our sample. You'll see that in the procedures. But I just wanted to point out those couple of things, maybe a little bit more close up than a slide would do. You'll also see that there's not threads on this piece either. And once again, we're going to get to a point of attaching this. So again, it's a matter of pushing and twisting, and you can get it on there nicely. All right, so don't get distracted by those threads and think you're doing something wrong. You're not. It's supposed to go like that. All right, the other stuff on that list is pretty straightforward, but I will I'll go back to that with sharing my screen. Okay, there we go. So when your equipment comes in the mail, or maybe you picked it up at the conference last week, you should have all this other stuff. You'll have vials with caps. You'll have tweezers, amber bottles. Just take a look through your kit if you have it now. If you're missing any of this stuff, we will have to get it out to you special. So you want to go through your equipment list and make sure you have everything that you should have. Now, this is only the case for people who are brand new. If you're a repeat chlorophyll sampler, you will have a lot of this already, and we don't give you all this stuff over again. Instead, we just give you the consumable pieces that get used up every year. All right, so now let's talk about the sampler. Oh wait, not yet. I was going to point out the filters. Okay, so your filters will look something like this. And this is very important because this is where people make mistakes. When you eventually use this in the chlorophyll filtering process, you want to be very careful that you're using the filter and not this bluish kind of wax papery. It's a separator sheet that goes in between the filters. What they do is they have these huge sheets of filters, and they stamp out circles, and each one of those filter papers is divided by these separator sheets so they don't stick to each other. And when we give it to you, we just count out the separator sheets and the filters and put it in this bag. So you'll have a mix of these things in there because we don't want all the filter papers sticking to each other. So you can discard these blue pieces of paper. That is junk. Do not use the blue pieces of paper in your sample. You want the white ones. They are fully opaque. This is why it tricks people up. The filters you actually use are fully opaque, and they may not look what you think a filter should look like. And people look at the blue, somewhat translucent piece of paper and think, oh, that looks more like a filter, so they use that. So it's tricky if you forget this training. It's obvious right now, but when in a month and you are just doing this independently, you may forget. So that's why I make such a big deal about it. This is what your sampler will look like. This is a homemade deal, but that doesn't mean it doesn't work. It does exactly what we want it to, which is why the program's been using this for over 20 years. And that's a lot of grape juice and baked beans, which is the base of of this contraption. And the point of this thing is to collect collect water in your lake from anywhere from 60 feet all the way up to the surface. So you drag it through the water column down to up, and it collects water as it goes. So it enables you to get water at the bottom, in the middle of your lake, at the top of your lake, all mixed together. That's why it's called an integrated sampler, because you're integrating all the water depths. So anyway, these are different pieces that are part of this contraption. You can fully take it apart. To do that, you'll have to take off the cap, you'll have to take off the rubber stopper, but then you can loosen that retaining chain and take out the amber bottle. And you need to do that. You need to be able to disassemble it to keep things from rusting out. At the bottom of your sampler, there'll be little weights, and those weights are not connected, they're not glued, they just sit there loose in the bottom of your sampler. So don't lose them, don't drop them overboard, they will sink to the bottom and you will never see them again. So you have to be careful when you're cleaning this thing to not accidentally tip the whole thing overboard, and that will be the end of those weights. If you've been in, I mentioned this already, but if you've been in the program already, you'll get a resupply kit, which is just the consumable pieces. So you won't have every little individual piece. Now, if you have lost something or need something replaced, you can get in touch with Jean Roth, who's our volunteer contact for equipment, and she'll get something, whatever you need, she'll mail it off to you. Then there's some things that you provide too. There's, of course, your anchor, your PFDs, again, pencil or a Sharpie, never using a ballpoint pen with ink that can run. You'll need a measured line for your sampler. We want you to use not a tape measure, which will tend to which doesn't have the amount of flexibility we need. We want you to use a rope of some sort, nylon rope, something that, and then what you have to do is put your own measurement lines on that, because you need to know at what depth you're throwing this rope out. So to do that, you will want to maybe just grab your Secchi disc tape measure and put them side by side next to each other and mark every 5 feet, every 10 feet, and then maybe every 2.5 feet in between those marks, so that you have a nice rope line that has proper depth measurements across it. And that's what you'll use and attach to your integrated sampler. So let's talk about a depth integrated water sample and how to get that. So you're headed out on your lake. You follow the same procedures as before. You go to that deepest point. You want to try to do this in the calmest water that you can. Typically, you're doing it between 10 and 3 p.m. For proper light conditions, because one of the things you're doing is taking a Secchi measurement. That's actually what you do first. So you'll already have been, out there to take for your normal Secchi measurement, and this is just you get to use that direct Secchi measurement. Here's a person filling out the data forms on the way out, and then you're getting that Secchi disc. So just as a reminder, what you do is you lower that Secchi disc until it disappears from view. You raise it again till you see it, and then you record the average of those two numbers. Why do we do Secchi disc if we're talking about chlorophyll? Well, Secchi disc is a measurement of how far the light penetrates into your water column. And this fun little graphic, I think, shows it pretty well. Our Clmp volunteer here has taken a Secchi disk depth, but light actually penetrates further than how far your eyes can see it. Your eyes see down to the Secchi depth, but light goes further down than that. And whenever there's light, there's going to be algae growing there. And experience and math has taught us that light penetrates to about twice the Secchi disk depth. So that is how far we're actually going to be lowering our chlorophyll sampler. That is the depth to which light penetrates. So when you take your Secchi disk depth, you just double it, and you have what's called this integrated depth. Composite sample depth is actually what it says on your data sheet. So here you can see a spot for Secchi depth, then you just double that, and you get your composite sample depth. Okay, so obviously this brings up some immediate questions. What if I can't double my Secchi depth for whatever reason? Either your lake isn't deep enough. So in any case, if you are not able to fully double your Secchi depth because you'll just hit the bottom, what you do is you want to bring your sample down to just about a foot off the bottom, and you record that as your composite sample depth. So you're not stressing about it in that situation. In that case, you just go as deep as you can without disturbing the sediments in your lake. You don't want to dump your integrated sampler down really hard and have it hit the bottom and cause a sediment plume shoot up. Get an understanding of the depth at your position, and don't hit the bottom of the lake with your sampler. Okay, so we're out there on the lake. We've determined that depth that we're going to use. And this is where you deconstruct your sampler, and you are being careful to not dump your weights overboard or dump your sampler overboard, but you do take out that big amber vial and you rinse it a few times to make sure there's no residual dust or water from last time you did this. So you clean that out, and then you can reassemble the contraption, and you are ready to go. Okay, so what you do is, so notice this fellow has his own line that he is using. He has marked this in some various fashion to understand the depth of the line. Then what you want to do is use a clothespin to mark the depth on your line to the depth of which the sampler is going to go. You want to take all that line, throw it in to the water, just holding it at that clothespin point so it doesn't go further than it should. And then you just release the sampler and let it free fall down. It will fall rapidly because it has the weights in there. And you stop it when it hits that clothespin at the water surface, because then you know you've gotten deep enough. Okay, when the line goes tight and you know you've gotten to the proper spot, you can slowly bring that sampler back up at a slow, steady rate. Now this will take some practice, but there's a way to judge how well you did when you slowly bring this up. That's because you check your water depth in this amber bottle. You want your bottle to be not full, somewhere between 2/3 to 3/4 full. The reason for this is if you pull it up and it's completely full with water, well, in that case, you can't really know at what point it filled up. Maybe all of your water that you collected is actually from the bottom of the lake, and you didn't get any of that surface water or maybe the mid depths of the lake. And remember, the goal is that we're trying to collect water over the entire depth. So if it's full, you know that maybe you pulled it up too slow. So then you would just dump it and try again, pulling faster this time. So it might take a few tries as beginners until you get a sense of, for your lake and for your particular sampler, how fast or how slow you should be pulling this sampler up. Now, if the bottle is too empty, it probably means you pulled up too fast and you may not have enough water to do what we need to do. So that's why we suggest 2/3 to 3/4. Okay, so once you have enough water and not too much water in that big amber vial, give it some swirls, some gentle mixing, and then you're going to fill up your 2 rectangular amber bottles. So these are smaller bottles that will come with your kit. You will fill those up. You will cap those. Oh, sorry, you don't cap them yet, because before you do that, you also have magnesium carbonate, and it comes in a little dropper bottle. And this little magnesium carbonate, you can do that vigorously. Really mix that up good, because the precipitate settles out on the bottom. So you want a nice mix there. When that's nicely mixed, add 5 drops to each one of those amber vials, cap them, swirl the amber vials gently to get that distributed inside. This is a preservative, and it starts stabilizing your chlorophyll so it doesn't break apart. And then you can put those in cold storage until getting back to shore. So that's only half the work, however, because there is an indoor portion to this sampling, which is filtering the water sample. Now, this is technical, and it has different numbers that you need to remember. So we actually made a video for this. I am going to stop sharing just for a second so that I can take this video address and put it in the chat. This is for your future reference. There you go. That's in the chat now, but I'm also going to bring it up in my computer now, and we're going to go ahead and watch it together. But so, eventually you'll get really good at this, but for the first couple of times, watch this video before you attempt this procedure. All right, so I'm going to share my screen again, and we're going to watch this video. Now, this video is pretty quiet, so if you can't hear it very well, my volume will be up all the way to try to get it to your computer, but you might need to turn up your own volume so you can hear it. We're just going to watch the filtering section. All right, so Joe, if I have anything wrong here, just interrupt me and tell me if it's not working. All right, it should be going. Here we are.
The best place to filter a chlorophyll sample is indoors, by a sink, and out of direct sunlight. Make sure you have all of the equipment listed. Ready to go? First, unscrew and open the filter holder. Use tweezers to pick up and move the filter. Never use your fingers. The filter is a glossy and opaque white circle. Be sure not to use the filter separators, which are translucent and look more like tissue paper. Center the filter on the screen and place the O-ring on top of the filter. Screw the filter holder back together until it is moderately tight and place it to the side for the moment. Grab the syringe and the small piece of clear plastic tubing. You can push the tubing onto the syringe. It doesn't fit perfectly, but it will not slip off if you work at it. Swirl or invert one of the amber bottles to mix. Rinse the syringe by drawing up sample water until the syringe is full, and then empty it. Then fill it up to the 60 milliliter line. With the syringe pointing up, tap it to force air bubbles to the top. Push the syringe plunger until the end of the plunger is lined up with the 50 milliliter mark. Attach the filter holder to the syringe. Like the tubing, it won't snap into place, but you can get it to fit snugly. Slowly push the chlorophyll sample through the filter holder and adjust your pressure to achieve a rapid drop rate. Pushing too hard may rip the filter, so avoid excessive pressure. As you push the plunger, make sure that no water is leaking out the side of the filter holder. If your sample has a lot of algae or other particles in it, it may become too difficult to push the full 50 milliliters of sample through the filter. In these situations, stop pushing and note how much water you were able to filter by reading the side of the syringe. There is a place on the datasheet for you to record this information. After filtering the water, separate the filter holder from the syringe and unscrew it. Using a safety pin and tweezers, fold the filter in quarters with the algae on the inside. The filter will probably stick a bit to the filter holder, and it requires a steady hand and some practice to do this job smoothly. Remember, never touch the filter with your fingers. Put the folded filter into a sample vial and cap it. Place a filled-out sample label onto the vial lengthwise so that none of the label is wrapped upon itself. Let's take a look at what a correctly filled-out sample label looks like. You need to use a fine-tipped, permanent black marker to fill out the sample labels. In addition to the basic lake information, write CA in the parameter code box and write MgCO3, which stands for magnesium carbonate, into chemicals added. Remember, you added magnesium carbonate in an earlier step. On the label for your second sample, write REP next to the lake name. This is short for replicate. You now have one sample complete. Congratulations! Now you get to do it all over again with your second sample bottle. Once both samples are complete, wrap the vials completely with aluminum foil to keep all light out. This foil wrapping step is critical. Unwrapped samples cannot be accepted for laboratory analysis. Write your lake's name and the sample month on the foil packet. The samples go into a Ziploc bag with your lake name, county, and field ID number. Fold the data sheet, place it into a separate Ziploc bag so it stays dry, and place it in the bag with your samples. Storing your data sheet with the samples is a good way to make sure the paperwork never gets lost. And then everything goes into the freezer until it is time to turn it in.
All right, I'm gonna stop that.
And Paul, while you're doing that, we had a couple of questions come in. As you're switching over, one of them, there were a couple of questions about receiving their chlorophyll equipment. And I just wanted to remind folks, I put it in the chat, but for most of you, that was just put in the mail yesterday. So keep an eye out for that over the next week. If you don't receive it in the next week, let us know and we'll track it down for you, but you should receive it within the next week. And then there was a question from Eric. He wanted to know, how restrictive is the 5 drops of magnesium carbonate? If I do 6 or 7, does that matter? Other than maybe I will run out of it before the season is over?
Is that Eric Elgin asking that, or
no,
is it a different Eric?
It's a volunteer.
Oh, okay. You know, I don't think anyone's ever asked that, so I'm not 100% sure. My gut tells me it's okay. What do you think, Joe?
I think you're right, Paul. The idea is to kind of saturate the sample with enough magnesium carbonate to preserve it. It helps stabilize those chlorophyll molecules. And so a little extra won't hurt the sample. But yeah, don't get too crazy because you might find your bottle getting a little low at the end of the season. All right, thanks. We're caught up on questions, Paul. Thanks.
Okay, good. All right. Well, we're going to keep going for a little bit. There's a few more things to cover. Some of this stuff, you know, we do the same for every parameter, so we repeat some things. Like, first of all, we want copies of your data forms, but electronic copies are fine. But for quality assurance, we like to have that. Keep everything frozen, just like with your phosphorus samples. Your chlorophyll needs to be in the freezer until you bring it in to your drop-off point. Thirdly, even though most of the work is done by the lab when it comes to analyzing your sample, we do want that information that goes on your data sheet, we want it entered into our database. So, and this is the case for Seki, for phosphorus. We love it when volunteers are able to enter their own data because it saves Gene a lot of effort. So there's instructions on our website on how to enter all of this information, and none of it is very hard. It's similar, you know, it's just filling in fields, typing in and going to the next field and then going to the next field. So a pretty simple process. I think I've covered the schedule pretty well at this point. So we'll just keep going. What are some reasons that samples are going to get rejected for chlorophyll? If you collect samples at the wrong time, you have a 10-day window for the most part. It's going to be the 10th through the 20th of every month. So that should be enough time to get out to the lake and get those samples taken. You know, the exception is you don't quite have 10 days on that final sample because that has a really specific interval that it wants you to follow. So just refer to your schedule for that 5th sample, which is a little different. If you try to filter your sample through one of those blue separator sheets, your sample will get rejected. We can't analyze that. It wasn't collected properly. Blue equals bad. Don't try to filter through a separator sheet. If your sample is not wrapped in foil, we can't analyze it either. That's because the foil is blocking out light. Light obviously is going to affect chlorophyll. I mean, that's how chlorophyll grows. So no light allowed to touch these things. Wrap them up in foil. You don't have to send in 5 feet of foil or anything like that. Just make sure it's fully covered. And then incorrect delivery, once again, same with phosphorus. If you can't follow the normal instructions for whatever reason, contact us for instructions to make sure those samples get to us safe. We don't want you leaving them at a front door anywhere or sending them in yourself without talking to us, because they will thaw and then they'll have to be rejected. Joe, did any other questions come up about the chlorophyll procedures or anything covered up to this point?
One question that maybe wasn't about the procedure, but just about the testing itself and the results was, what is the minimum detection limit for the Chlorophyll-a test method? And as the person who sees all those data come in from the lab, I can address that one. We get, the lab will, the state environmental lab sends us the results from analysis of all of your samples, and they give us a reporting limit. That means if a sample comes in less than that reporting limit, they report it to us as undetectable. And that limit is 1 microgram per liter, which is also the same as 1 part per billion. I think in our reports, we say parts per billion. So if you're below 1.0, the lab will tell us that chlorophyll was too low to be accurately detected. So that's a real good question. And then, yeah, there was another direct message I got, some discussion that we had about what if I just lost one piece of my sampling kit? Do I have to buy a whole new one? And the answer is usually not. Reach out to Jean Roth, and she may be able to send you a replacement piece if you just lost or broke one part of it. But if you need a whole new one, you can order a new one off our website. And I think we're caught up. So you can move on.
Yeah. You'll notice that we always put up pictures of this particular person when we talk about stopping for questions. And I think it'd be remiss of me not to recognize Ralph Bednarz, who led the Clmp for years and years and years, created many of its procedures, figured out the chlorophyll equipment, built this stuff. And is now a volunteer on his own lake doing these procedures. And we just want to appreciate Ralph for all the years that he put in for the Clmp. And, trained me in this, trained Joe in this, worked with Jean for years and years. So just an important person to this program. So one of my jobs is working on the data for the Clmp. So because this is my turn to talk, it's a good opportunity to go over this so you can kind of know what to expect when you get your data reports. Data is all the data entry that we ask you to do is due by October 31st. Usually we don't get the actual results back from the lab until mid-December, sometimes late December. Then we have the holidays in there. So come January is usually when I'm busy working hard compiling all this stuff. And it takes a while. It's basically my full-time job for over 2 months. It's just going through the process. So it may take longer than you think it should for you to actually get your results in hand. I just wanted to acknowledge that, just tell you that we are doing it as quick. So when everything's ready, often in March, we will send you a report like this. This will be the 3rd page of your report, and this is kind of your basic overall summary of what's going on your lake. You'll see we have sections for each of those trophic parameters. We have a section for dissolved oxygen in the bottom corner. When you do dissolved oxygen, you'll be making anywhere from 5 to 15 of these dissolved oxygen measurements per year. On the summary page, I just show a single one, and this is I usually select this particular profile to show at what point your lake is really starting to stratify. But all of your profiles will be included at the back end of the report. And then there'll be some narrative in the corner that talks a little bit about a summarization of what the numbers mean. Okay, we had a chance to blow up on those in a second. So in addition to that summary page, you'll also get full-size graphs for each component over time, as long as you have more than 2 years worth of data. We'll give you the dissolved oxygen profiles. The score of the shore results will be in here. The aquatic plant results will be in here. And you know, I do a lot of these, close to 300. So chances are I'm going to make a mistake somewhere. And if you do find a mistake, email me. I'll fix it as quick as I can and get back to you a fixed version. So let's just blow up on one of those particular boxes, this one being chlorophyll, just to give you a quick explanation of what's going on here. The top line is always going to be that current year. So the samples you took for this particular year. For this lake, they got all 5 samples in. Their samples ranged from, when it shows that less than sign, less than 1.0, that means they hit that lowest reporting limit. So as low as the lab can detect, that's what this particular lake had. Their max was 5.2 parts per billion, and then their median of those 5 measurements was 2.2. There's a note of the amount of spread or standard deviation around that. And then this thing called Carlson TSI. This is something that's calculated from the median. And this is a rating that will then tell you your classification. Are you oligotrophic, mesotrophic, eutrophic, somewhere in between there? We'll talk more about that in a second. The next line is the 5-year recent history of chlorophyll on your lake. And then we'll include the third line is your entire history, you know, your older data. I would love to just give a breakdown of every single year, but obviously then it wouldn't be a summary sheet, it would be the full data set. So if you ever want the full data set, you can definitely get that yourself, download it as an Excel from our data exchange, and you'll have all that data, and you'll see every single measurement that you made. And then the bottom line is a summary of everything every lake that was enrolled in this parameter for this year, what the average across those, well, the median across all of those lakes who were involved. And you'll see similar boxes for phosphorus. You'll see similar boxes for Secchi, and then a little graph showing you the trends. The bottom corner will have a summary. It will show both the TSI number for the current year, for the last 5 years, for the overall history of your lake, and then comparing that to how you do against other lakes in the program. It's important to note that these are lakes who are all opting into the Clmp. This is not meant to be an overall average of Michigan lakes. We can't make that claim. It's just those 250 to 300 lakes that enrolled in that particular year. I give a little bit of explanation of what the numbers mean. I talk a little bit about your dissolved oxygen in this summary. I talk about a long-term trend, if there is any. And these long-term trends are not concentrating on one particular parameter, but looking at all of them. So sometimes you may have Secchi that is stable and phosphorus that is changing, maybe going up, and chlorophyll is actually going down. So it's a bit of a judgment call when you're looking at all 4 parameters at once to say what exactly is going on here. I give it my best shot. Obviously, data is a lot more nuanced than simple sentences. This is really just meant to be an overall picture for you. So let's talk more about trophic status index and then what that TSI, that Carlson TSI number means. And this is kind of the easiest way I can think of to explain this graphically. So basically we have three measurements. We have your Secchi depth, which is measured in feet. We have summer phosphorus, which is measured in parts per billion. We have median chlorophyll, which is measured in parts per billion. These are measuring different things. They're measuring them at different scales. So if you were just to try to compare one number to another number, you just can't be done. They're different things that we are measuring. But a scientist by the name of Carlson came up with a way to scale each of these to put them on basically the same scale, for lack of a better word. Putting them so that they can be compared to each other just by transforming them mathematically. So then once you run your results through these equations, you get what is called the TSI number. You get a TSI for Secchi, for phosphorus, for chlorophyll. And then if you wanted an overall average TSI for your whole lake, you just average those three numbers. So that's, when we're talking about TSI, that's kind of where it comes from. And then I like to envision this TSI scale as a thermometer of sorts, where on the left-hand side, you have oligotrophic, which are your low nutrient lakes. And on the right-hand side, you have eutrophic, or eventually when it gets high enough, considered hypereutrophic, extremely nutrient-rich lakes. And you can graph out where your lake falls on this. It's a classification system, so you're putting these numbers in on here, and then you can slot your lake into a particular group. This particular lake is in the oligo/meso group, so it falls somewhere between oligotrophic and mesotrophic. It's important to remember these numbers are very much a continuum. They change over time. Your lake will change over time, and so one year you may get results that are oligotrophic. Maybe the next year you might see a spike in phosphorus, and you might be up at 40 and pushing mesotrophic. So your lake does change over time. Year-to-year changes aren't generally too concerning. It's when you see repeated patterns year after year after year where you can really get a sense that your lake is actively changing. So don't respond too strongly to any one particular measurement that's bad. What you may consider bad or high. But it really is that long-term data that is important to look at. So this graph will be in your report. So I guess that's all I really have to say about your report, but I could take questions on it, of course. And just as a quick snapshot, I haven't made one for 2021 yet, but for 2019, you can get a sense of where the different lakes in the program are, and whether they're mesotrophic or eutrophic, and where those are located. So typically in our program, the majority of lakes are mesotrophic, almost oligotrophic is typically the majority of the lakes. Those are, and I think that is a very normal lake in Michigan. We do have some lakes that are higher on the nutrient scale and considered eutrophic. So that's my presentation. We have plenty of time before our next break, so I'm happy to take questions, but we can also end early for your lunch. So what do we got, Joe?
Thanks so much, Paul. We haven't had any additional questions come up in the chat. But I will say, since we do have quite a bit of time, if folks have questions about anything we've covered up to this point, feel free to pop it in the chat right now. Or if it's a question that you're not quite sure how to type it, or you think it might be long, we also have the option where you can raise your hand. We can call on you and you can turn your mic on and ask it audibly if you'd prefer to do that. So if anyone wants to raise your hand, all you have to do is go down to the bottom of your screen. You'll see a button that says reactions. If you click there, you'll see an option to raise hand. So we'll just kind of wait for a moment to see if anybody else has questions about chlorophyll, about the annual reports, questions about SECI or phosphorus. We have plenty of time right now. Otherwise, we will be reconvening after a lunch break. Lunch will go until 1 o'clock. We'll be back here at 1 o'clock to start on dissolved oxygen. We're going to leave the Zoom open during the lunch hour. We'll just turn off our mics and cameras so you can disconnect and come back, or just leave your computer on during lunch, whichever you'd prefer to do. And we'll be here and we'll start promptly at 1 o'clock. All right, I'm seeing a couple questions come in. I knew they would if we gave you all an opportunity. So one of the questions that has just come in from Ellen, she asks, there has been a lot of publicity about runoff from road salt. Why doesn't the Clmp include chloride? That's a great question, Ellen, and I'll start talking about that, and others can chime in if they wish. We don't include chloride right now, but that doesn't mean we won't in the future. You're right. There's been a lot more awareness recently, especially across the Midwest, about the importance of chloride and salts getting into our lakes. And so we're always thinking about new categories to add, new parameters to add to the Clmp. And so thanks for letting us know that you're interested in that. That gives us something to think about for sure. So thank you very much. Next question from David. Might 1 milliliter syringes be used to measure the magnesium carbonate more accurately? They could. We haven't seen Paul say, well, yeah, they could. But again, as we mentioned before, accuracy is not terribly important for that preservative. We just want to make sure you get enough in there that it will stabilize that chlorophyll molecule. And as you might imagine, syringes and extra bottles are more expensive than a simple dropper bottle that lets out just about enough with those few drops that we ask you to add. So I think we'll probably stick with that, but absolutely right. Something that measured would be more accurate, but accuracy isn't terribly important in this case. Another question, we participate in this program on our lake. My question is there any way to apply these tests to the canals that connect to our lake? I don't have to answer all the questions. I saw Eric turn his video on. It sounded like I'm guessing he's eager to answer this question. So
eager, yes.
Go ahead, Eric, as our lakes program manager, you can address the canal question.
Yeah, so you certainly can use what you've learned from the Clmp program and how we do our measurements to canals, but it wouldn't be part of the Clmp program. We are creating, our baseline data collection requires us to be consistent in location, and that's to create a standard that we can compare through the years and between lakes. And so if you're collecting it in a canal, you can't necessarily compare that to lakes that are being collected in the middle of the lake. And so, yes, you can learn what many of these, total phosphorus is a great one, chlorophyll, you can use in canals, but you would have to do them outside of the program.
Thanks, Eric. Great question. Mark made an observation that it seems that plotting the trophic status index over time would be a good indicator. Paul responded definitely, and I think we all agree, yes. Looking at your TSI over time is definitely something we encourage you to do. Keep an eye on that over time because it can tell you a lot about your lake for sure. So great observation. Next question from Betty. Does this testing include results shown from agricultural runoff, fertilizers, or air spraying of fields near lakes?
I can give a first
Sure.
crack at it. So phosphorus is a main fertilizer used in agricultural areas, also in lawns. People still use phosphorus on their lawns. And so our phosphorus test may be able to detect changes in the watershed in fertilizer use and runoff with that, and through time especially. We won't be able to trace it back directly to those. So phosphorus is coming from all over the place. And so that would be a much larger study to try to trace it back. And those are called nutrient budget studies. So where are the nutrients coming from and where are they leaving? Think of it as a budget. As for the air spraying and stuff, so those, I'm assuming those could be like herbicides and different pesticides, and we do not have any parameters for those. And you could investigate that by contacting either Eagle, the Environment, Great Lakes, and Energy, and you can have a conversation with them with what's the best way to go about that, or a private company may be able to help you.
Thanks, Eric. That's a really great response. And Betty put her thanks into the chat for that as well. And I'll just add on, we'll put a link in the chat for how to find your local Eagle district office. They can be a really great resource for questions like this that maybe go a bit beyond the scope of the Clmp and of MiCorps. If you have concerns about the environment, they are there for you. And so we'll put a link in the chat on how to find those district office folks and send your questions their way. And yep, there's Eric already got on it. So you can find your people that way. Great. So other questions, I think here's one. How does the moth formerly known as, I feel like I'm talking about Prince here, the moth formerly known as gypsy moth, they now call them spongy moths. How do they affect pH and chlorophyll results? I have no idea if there's a relationship or not. Is anyone aware of any information on that? I
am not. I'm just trying to think of some mechanism. So let's say a particular lake shed is defoliated, heavily defoliated. And could that change runoff dynamics if there's some heavy rains prior to the oaks re-leafing out? That's just me kind of thinking out loud, if there could be something there, but I can't think of anything. I would be curious, there are pesticides that are used on gypsy moths at a landscape level, spongy moth. And let's hope that, I'm assuming there's good practices for those not to be sprayed over our lakes.
Thanks, Eric. I did a super fast Google search. I found a report from the U.S. Forest Service about that looked at all sorts of impacts that may happen from spongy moth infestations. And they're similar to what you were thinking, Eric. They wrote that slight short-term increases in water temperature may be found because of that loss of shade. That we might also see decreases in dissolved oxygen slightly, again, because the water is getting warmer and warmer water holds less oxygen. But they also state that long-term effects should be few. So if it's a sustained outbreak over a long time, you might see small streams get a little warmer, but lakes shouldn't be affected. So that's good news, I think. All right, we'll keep going. Molly just made an observation that there was some spraying by the county and it happened over their lake. Another question about spongy moths. What about excessive moth excrement, which can be, in all caps, excessive? I don't think we know, James. I'm sorry. You might ask around. The Forest Service or the DNR may have more information on that. But yeah, this is a real issue in some parts of the state. I remember last year's season and seeing the forests that were really in really kind of temporarily bad shape as far as having their leaves pretty much missing. And so, yeah, very, very interesting questions. And it makes me curious to learn more about it.
In ecology, it always comes down to poop.
It does in so many ways. Poop.